G'day team, once again welcome back to CEW.Manufacturing. I'm still Matt. This here that you can see is the back end of my lathe. It's it's a work in progress. I built the whole thing, if you haven't heard me toot my own horn before. Just to orient you to what you're seeing. Down here is the drive pulley coming from the servo motor. You can see it tucked in behind the back here. Up the top here is my spindle, it's the back side of that. This is the same size pulley as on the drive, so the drive and driven's pulley are the same size for a 1-to-1 ratio. Because the servo motor with a 1-to-1 ratio, I should be able to use the servo motor to give you accurate positioning and indexing and all that kind of jazz. However, I have two other pulleys that I want to be able to put down the bottom end there to enable me to get a high speed and a low speed or different ratios. So because of that, I need to have a spindle speed up here directly reading off the spindle. So that's what this little chip here is. At the moment, it is on this cross brace here, reading off a reflective pattern on the back of the actual spindle drive pulley. These brass bosses, you can see one here and one here, are actually designed to have aluminium pieces in here that bond in and then will act as a spindle brake. So that'll go there and that'll clamp on the face inside here. Because this is a servo motor, when it's in the 1-to-1 ratio, I should be able to use the lathe as a 4th axis mill. That's the plan. But I need those spindle brakes in there to be able to provide a bit more rigidity to the whole spindle setup. So what are the problems I have with this currently? One, this is 3D printed plastic, not aluminium or steel or something. Same goes for these brake pawls here. Both of them need to be changed out for aluminium counterparts. Two, when I was machining out this drive spindle or the drive pulley, you can see it actually doesn't have a cam lock like the bottom one does. It's been bored out and then it's been cross drilled. I knocked this gate thing here over on this side off to try and hold it better. That means that the optical encoder is really, really down low and doesn't actually have a very good view on the encoder wheel. Further, the encoder wheel there I used the wrong ink on, so it only picks up like every second division. And finally, that's a really fast spinning belt. It's a great pinch point and it's just not safe. So basic safety considerations. So what I'm going to do here is I'm going to make a new one of these pulleys up. I'm going to make this cross bridge up here out of aluminium. I might get around to these brake pawls, I'm not too sure. And I'm going to make some kind of little enclosure-y thing that'll cover down there so I can't get fingers or errant pieces of cloth or other bits and pieces trapped in it. Anyway, so that's what I want to do. Time to crack on. So you can see I've got it all set up. I've indicated the pulley in, so it's only got 0.05 millimeters of run out. Couldn't get it any further than that. I've done a very, very light touch pass on the inside of it just to find out where the initial start point was. I've got my first set programmed and we're going to go from here. It's hardened steel, so it's the first time I've done hardened steel. That's a lie. I did it on the little pokey thing. But it's hardened steel. It's proper hardened steel. We'll give this a go. So I didn't have all the tools I needed to do this job at home. I took it into work and I got these holes drilled in counterboard. I can't show you the video from that because I'm allowed to have cameras in work, sorry. But trust me, it was drilled in counterboard. Evidence. So I've given this whole back end here a clean, and what we're going to do now is put the encoder ring on. So the encoder I use is from a company called Masso. It's an Australian Indian conglomerate, I believe, that sells CNC turnkey solutions. I've used their encoder on my lathe because it was a reflective optical encoder, and I was able to mount something on the back of this wheel here. So I've just cleaned this surface here with some methylated spirits. It should be a nice, good surface for this sticker to adhere to. So this encoder wheel comes part of the Masso spindle speed encoder setup. It's available on their website just to get this wheel for anyone, but the encoder itself reflects light off the sticker and then back out. I previously used an inkjet printed sticker and it registered the whole thing as white. It never actually registered anything as black. I contacted Masso, they were super helpful. They got back onto me really quickly and they said use a laser jet or a laser printer. So I've borrowed a mate's laser printer, supplied my own paper, and just got this this cut. I've tested it by waving it in front of the sensor, and it seems to work. So we'll see how it goes when it's actually running on the lathe. So the thing I hate about incremental upgrades is I'm now at exactly the same spot that I left before. I have a pulley that connects my motor to my spindle via a belt. Done. I've literally achieved nothing in all of this. I mean, like, it has an extra fence on it now, but I've literally achieved nothing. However, I've found a problem. And that problem is I was meant to take this ring off here, this retaining ring for the bearing. I was meant to countersink that so I can get rid of these screws for the brake system to come into. So I'm pulling the whole thing apart again. So before, when I was complaining about being done, but not being done, now I'm not even partially done. So you can see I've been through a few iterations here, but I now have an encoder bracket that actually works and holds everything in the right spot. Before we commit to making this out of metal, I just thought I'd go and show you something that's happening. It's a bit weird with the encoder, but it's not a war stopper. So this is the Mac 4 screen here. Yes, I am recording the screen using another camera. This computer isn't strong enough or powerful enough to support a screen recording tool. So you see here, the spindle programmed RPM is 500, and up here is the actual reported RPM by the lathe. So if we just start this, if you ever have a look there, you can see we've got between 400 and 500 kind of RPM. It's not consistent. I don't know why. If we bring this up to a bit faster, we're getting more and more accurate the faster it goes. So I suspect we've actually got too few sectors on the encoder. So I don't know what to do about that. And it kind of gates as well between two different values. So it's in the right ballpark. Yeah, so I'm not sure exactly what's driving that. I don't know why that's doing what it is, but it's working at the moment. I've done some threading. The threading seems to work. I've also done some constant surface speed turning, and that seems to be pretty consistent. So I'm going to leave that for the moment and say it's working, with a big asterisk next to it. So that fits. I was a little bit concerned about the electronics on the back of the board here. It looks like I actually have nothing to worry about, but just to be safe, I put a bit of duct tape over here, over the bar to act as an insulator. There seems to be nothing in here that's going to short, but it's done now. That's a nice solid little mount now. That's good, but there is one more stage left to go. So we're over here at the magic part making machine, and we have one little cover. Let's give it a bit of a clean up, and then we'll go and install it. Sweet, that's a good little upgrade. And it'll stop things from getting in there, provide a bit more shade through to the sensor here so that the IR light doesn't get affected by the sun coming through the window. and it doesn't touch on anything. It's a good upgrade. So you might be wondering if there's anything planned for the rest of this belt, and yes there is. There's actually a couple of holes in this 3D printed bracket here that'll enable me to put some side bits on, and then I've got another one I'm going to do up for the bottom here, so this entire back end here will be enclosed. Still has pass-through for material. I am quite happy with how that's worked out. So I'm not going to cover off any lessons learned on this one, so I'd like to say thank you for your time for watching. If you like my videos, please consider subscribing. Otherwise, just, have a good day. That's good.